Good afternoon and good morning to those of you out west. Welcome to today's demo cast from the Construction Specifier and Kryton. My name is Carly. I'm the managing editor of the Construction Specifier, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started. If you have any questions during today's demo cast, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, please only use the Q&A instead. If you're experiencing any technical difficulties during the demo cast, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's demo cast is being recorded and will be available on the Construction Specifier website by this time next week. Now, I'd like to introduce our speakers, Jeff Bowman and Christian Warren. Jeff is a key driver within the Kryton R&D team with more than a decade of dedicated experience in defining and developing best practices within the admixtures and repair materials category. He has written extensively on waterproofing technologies and has helped to develop new products that ensure structural durability. With a CIM degree from MTSU and more than 13 years of technical territory sales and operations management experience within the construction industry, Christian has worked for a large ready mix producer and admix companies. With a technical background in ready mix as the Mid-Atlantic QC manager, along with successful territory sales management, he brings a unique blend of attributes to support Kryton's ever-growing customer base. Today's democast will review the best practices for replacing conventional below-grade externally applied membranes with a crystalline concrete admixture waterproofing system, from design details and specifications all the way to best practices during construction to ensure the project is watertight and leak-free. Jeff and Christian, we appreciate you joining us today. Please take it away.
Thank you, Carly and Construction Specifier for inviting us to take part in this webinar series. As you described, I'm Christian Warren, Kryton's Eastern U.S. Territory Manager, and with me today, Jeff Bowman, our Technical Director. So today's topic is very exciting to us as we are finding that design teams are moving away from membranes and coatings like epoxies and are turning towards high-performance concrete to improve durability, sustainability, and to extend service life. So again, please submit any questions, and at the end, Jeff and I will do a Q&A session. So you'll notice a number of themes that resonate throughout today's presentation, such as waterproofing concrete, the methods of waterproofing, crystalline technology within waterproofing, and the systems that are involved, along with warranties. So why does waterproofing matter? Why is it important? The idea of wrapping the below-grade structure in a protective barrier sounds logical, right? But in reality, there are a lot of job site obstacles that make this very difficult, such as having a proper concrete surface, having the proper environment for the installation, having qualified tradesmen installing the membranes, and then proper site conditions. Now, we really hope everything goes according to plan, but more often than not, Murphy's Law applies. So here are some issues associated with external membranes.
Yeah, let's take a look at some of the challenges here. So our first example is a pre-applied composite membrane, and it's being prepped for blindside shotcrete. So far it looks pretty good, but let's look a little bit more closely. First off, you'll notice that the shoring behind the membrane is actually quite irregular. There's a lot of openings, there's a lot of gaps, which means when the shotcrete starts to impact on the surface, it's going to cause the membrane to buckle, and that can cause failure and leaks at the seams. Now, this is made worse by the fact that we can see that even before it's being installed, a lot of the adhesive along the overlapping seams is being compromised by dirt, despite the best efforts of the installers to prevent this. Now, take a little look farther up the wall, you'll see there's an awful lot of soil anchors. Now, these are all very finicky to detail around. It's very hard to get all of them right. So there's a high chance that at least some of those are going to be compromised and are going to leak. Now we'll look at another example here. We've already highlighted that the seams are a natural weakness in this type of system. And now the panels are actually narrower, so the number of joints and seams has actually increased. Now, when you combine this with some of the odd detailing, irregular shapes, a lot of the penetrations, it becomes even more challenging. And the other problem that we can see is that in the rotation of subtrades and people coming in and out trying to do their jobs, is sometimes we just get these unintended penetrations like this nail that's been installed right through the membrane. And it's very subtle and it's easy to miss and not be corrected before the concrete is in place. So now what will happen is, despite relatively good conditions on both of these sites, we're already seeing some of those early warning signs that can result in a failure. So you're going to wonder what's going to happen next. Well, you can see that these membranes are not accessible for repair once the concrete is in place, which means that any leaks and water getting around them is going to expose weaknesses in the concrete. And those repairs now need to be made to the concrete itself. So what will happen is, over the life of that structure, the responsibility and the function of waterproofing is going to transition from the membrane to the concrete, which is being increasingly patched up over time. So I think you can see now that it would be much more efficient if the concrete and the building could simply be designed and made waterproof in the first place.
Yeah, and it's easy. What do? You add waterproofing to the concrete. It's really as simple as it looks. It's 1 bag per cubic yard is added to the mixer truck right in the batch plant. Crystalline admixture becomes a permanent part of the concrete matrix and will hold back up to 460 feet of hydrostatic pressure. This turns your concrete into the membrane, solves the issue of permeability at its core. So can concrete fully be waterproofed? Yes, the American Concrete Institute supports this. The ACI 350 code requirements for engineering concrete structure states it is more dependable to use quality concrete, a proper design of joint details, and adequate reinforcement than to use a protective barrier. ACI also references the use of a system for membrane-free waterproofing. This is not a new idea. The integral system has been in use since 1984, and it's designed to replace externally applied membranes. Adding crystalline to the concrete reduces shrinkage crack size, will self-heal the cracks, and can, again, hold back up to 460 feet of hydrostatic pressure. So crystalline admixtures react with either unhydrated cement or free lime as a catalyst. The crystals grow in the pores and capillaries to become a permanent part of the concrete matrix, forming a protective barrier holding out water. They cannot be washed away or worn away. They don't grow and shrink like a clay-based material. The crystals maintain their structure. Now, Jeff is going to discuss what is needed for a crystalline waterproof system.
And this is a very important point. We've introduced the admixture so far, but what we're really talking about here are complete systems. So you want to make sure that you're specifying a complete manufacturer's system. And that would consist of the admixture and any accessory components for waterproofing joints, penetrations, but also with an eye to repair or remediation for any construction deficiencies that may need to be addressed before the building is handed over. I think we can all understand that there's a significant difference between a piece of waterproof concrete and a waterproof building assembly. So for guidance on this, there are many resources you can look to from ACI and other creditable sources. You'll also want to take advantage of the manufacturer's design review and site support. And at this stage, you should also be looking to review any manufacturer's warranty and extended performance warranties that may be available for your project. One really good resource you can look to learn more about these products is ACI Report 212 on chemical admixtures. In particular, permeability reducing admixtures are discussed in Chapter 15. Now, Chapter 15 describes the materials, the role and function and capabilities of this class of products, and it broadly breaks them down into 2 categories. Those are permeability reducing admixtures for hydrostatic conditions. Now, these would employ some sort of physical pore blocking mechanism, such as crystalline growth, that is able to physically block the pores and capillaries against water penetration and maintain that protection over the long term, even when exposed to high hydrostatic pressure, like you might get in a water tank or in a below grade structure. Now, these would be different from a permeability reducing admixture for non-hydrostatic conditions, or a PRAM. This type of product would normally be a hydrophobic material, something that provides some low absorption, water repellency, kind of like a rain screen effect. Now, these can be good for above grade use, reducing efflorescence, but they don't actually block the pores. So if there's ponding water or hydrostatic pressure, that water can still be pushed into the concrete. So only a PRA would be suitable for a waterproofing application. Now, Chapter 15 further gives some performance guidelines on choosing a PRA as part of a waterproofing system. In particular, it recommends that the product should have a demonstrated ability to reduce water permeability by at least 50%, and upwards of 90% and more have been reported using high hydrostatic pressure standardized testing. It's also important to make sure that product has a demonstrated ability to self-seal cracks during the life of the concrete to make sure that protection is complete and continuous. And reviewing Chapter 15 and its guidelines in their entirety, it becomes obvious that only a crystalline admixture is able to achieve both of these performance goals. Now, in making your final decision, it can still be a little bit more challenging because there's lots of different products and they make similar claims and often use very similar language. So it's important at this stage to make sure you're really reviewing exactly what the admixture is able to do. Does it have credible testing showing it can resist hydrostatic pressure? Also, does it have credible testing it can seal cracks? You'll want to really assess the credibility of these reports. Look for anything tricky where maybe the concrete samples have been prepared at one location and then simply delivered to a testing lab, but there's really no confirmation or verification of what's in that concrete. How has it been made? How has it been treated? One way you can help protect yourself is to look for test reports that are either published or referenced by highly credible sources such as ACI or other construction product accreditation bodies such as the BBA based out of the UK.
Now let's take a closer look at performance testing to the critical elements of waterproof concrete, starting with permeability. So the DIN 10485 test method is designed to model concrete in the real world. This test and BS 12398 are equivalent and recognized tests that measure the depth of water penetration into concrete samples. Permeability tests require specialized equipment and cannot be done by all testing agencies. So products that are required to resist water under pressure must be evaluated using this test method. Now, the test method is as follows. You cast and cure the samples, and the test is normally carried out when the age of the concrete is 28 to 35 days. You place the samples into sample holders. Apply water pressure of 72.5 psi on one end of the concrete specimen, while the other end is free to normal atmospheric conditions. Keep the pressure on for 3 days. Next, split the concrete samples and measure the average depth of water penetration. Now, let's switch to self-sealing of cracks. We know that concrete cracks, as Jeff mentioned, ACI requires self-sealing for the life of the concrete. Using a crystalline admixture will increase the self-sealing performance. Much can be done to reduce the size and number of cracks in concrete construction, but over the concrete service life, microcracks are unavoidable. So if the crystalline concrete is unable to self-seal these cracks, water flows freely and not only creates leaks, but also creates corrosion. Little cracks turn into big cracks and deterioration of the concrete and reinforcing steel occurs. This is one of the most critical performance properties for waterproof concrete. So Kryton, we are an expert in this field. Kryton and the BCIG actually invented and patented a very accurate test method used to measure self-sealing performance. This test, along with our method of inducing cracks to get consistent crack sizes, is not only used in our lab, but also in others, including the British Columbia Institute of Technology. So with this test, hydrostatic pressure is applied to the cracked concrete and measures the flow rate through the crack over time. And this is what they learned. The graph shows how the self-sealing of concrete is greatly enhanced through the addition of a particular crystalline admixture. The dotted red lines show the control concrete samples with 2 different crack sizes and the resulting water flow, while the blue lines are for the crystalline treated samples. So this testing not only shows that the treated concrete stopped the flow of water through the crack, but also that it demonstrated that this particular crystalline product self-sealed cracks of 0.6 and 0.7 millimeters while stopping a water flow of over 152 gallons per day. So to be confident in a product's self-sealing ability, specifiers should look for an admixture and a dosage level with independent testing guaranteed to self-seal cracks of at least 0.5 millimeters. So here's an example of crystalline self-sealing at work on a crack that's leading to a keyway. You can see the needle-shaped crystals clearly visible. So you will require an adequate concentration of crystalline in order to grow crystals that will self-seal the cracks that form. So when you increase the dosage, you increase the concrete's ability to self-seal consistently. So when specifiers attempt to save a small amount of money by going with a low dosage product, there's a major risk for leaks that are unable to self-seal. This leads to real-world issues such as corrosion.
And I think this is an excellent topic. Waterproofing, keeping water in and out of the structure is very important, but protection of the reinforcement against corrosion can be just as important, sometimes more important to some projects. Now, certainly waterproofing and corrosion resistance absolutely go hand in hand, and there's plenty of research showing that having low permeability is a very strong predictor of durability and corrosion resistance. So in addition to waterproofing and watertight construction, crystalline systems can also provide excellent protection against corrosion. Now, a really interesting study on this topic was performed by the University of Hawaii. This was a completely independent study where they exposed reinforced concrete panels in the harbor zone for 10 years. So what we're getting now is all of the critical corrosion-inducing mechanisms were acting on these panels. Not only was there high chlorides from the ocean water, but you're also getting wetting, drying, and exposure to carbonation at the same time. And these panels were treated with a variety of materials and waterproofing admixtures to assess their performance. So let's take a look at what they found. First, I think it's really important to mention that the control concrete in this example was a good quality mix. It had a water cement ratio of 0.40, so it was appropriate for the exposure conditions. And yet within the 10-year period, they did see high half cell readings and corrosion-induced staining and cracking in the control concrete. Now, by comparison, a crystalline admixture was able to vastly outperform the control concrete, maintaining low half cell readings with no corrosion-induced staining or cracking during the testing period. Now, at the same time, there were other permeability-reducing admixtures, including crystalline types, that showed sometimes inconsistent to poor results. Now, it's really important now to really highlight this difference in performance. This exactly illustrates why, when you're choosing a product and choosing a system, it's important to really dive into the history and the testing behind those products when you're making a decision.
Now that we've spent some time reviewing waterproof concrete, let's talk about the supporting details, starting with water stops. So here are 3 options that may be selected based on your specific project needs. And 3 products are a slurry, which is a crystalline treatment that would be used for damp proofing on the joints, a non-shrink crystalline grout used for keyways and tie holes, along with the use of a hydrophilic swellable elastomeric rubber water stop. For high-risk projects, a robust triple protection system may be designed using all 3 water stop products. For pipe penetrations, there are 2 options as well: external grout method or internal swellable water stop around the penetration before the concrete is poured. Of course, we can't forget about the tie holes. So if access is available to the exterior, a non-shrink crystalline grout is installed on both sides of the wall. An important reminder is to ensure that the substrate is properly prepared to receive a water stop. We see far too many construction joints like this that will require some chiseling, and this can be addressed early on in the pre-construction meeting.
I think this would also be a good time to turn to proper and effective crack control in your project. Even when you're using an additive in a system that's capable of sealing cracks, it's still in the best interest of the project to control those cracks as much as you can. So let's take a look at this quote here, which I really like it a lot. It goes, "We can design cracks that are pleasing to look at. They are called joints." Now, I absolutely agree with this, but what we have observed is that the most common spacing used for control joints in foundation walls doesn't quite provide the optimal level of crack control that you would be looking for in waterproof construction. And you can have a far better experience if you simply bring the joints closer together, so you have a maximum spacing of somewhere between 10 and 15 feet. Now, using control joints in this way makes the walls look very neat and orderly. We've all discussed that the concrete is going to crack, so you may as well make it crack where it's convenient to you and where you can address those cracks on your schedule. And doing this effectively can actually save time and money over the course of a construction project. Now, there are two ways that you can do this. If you have a traditional two-sided wall, you would modify your formwork in order to cast a keyway on each side, creating a plane of weakness, inducing a crack at the location you have chosen. These two keyways can then be grouted at any time, rendering that joint watertight and allowing work to continue in that area. Now, if you have a blind-sided form, the system is slightly different. You would start by installing a base seal PVC water stop to the shoring, then placing your concrete and casting or forming a keyway on the interior face that is aligned with the center bulb on the PVC water stop. This again induces a crack at a location of your choosing that can be grouted at any time to complete the assembly. So let's take a look at the kind of results you can get using this system. The joints are kind of hard to see here, so we'll just highlight them so you can see where they are. You can see everything looks very neat, very clean, nice and dry. But most importantly, we have essentially eliminated any sort of random cracking on this project. So this gives you this is always the fastest and most effective way to bring a building to a watertight state during the construction period. Now, if your builder is accustomed to using longer joint spacing, they might be a little bit uncertain about adopting this approach, but I can assure you that if you don't install these joints at the optimal spacing, the wall will just go ahead and install them for you. They just won't look as nice and they're never as straight.
And, we will always do our best, right, to design a watertight structure. We'll take care in how we place and cure the concrete, but still, as we all know, the cracks and defects will happen. So this is the world of construction, but that's okay because many of the cracks will self-heal. And for the larger defects, beyond the limitations of the admixture, there is a repair process. It's simple to do and can be addressed at any point during the construction process with no impact to the schedule. So addressing these potential areas early on avoids any unnecessary stress and callbacks. Crack repair is part of the system to deliver fully waterproof construction. So it's important, however, to keep an eye on scheduling the repairs before it does conflict with critical path items like elevator installation or before losing access to an area such as equipment like an HVAC system. Now, it's also important to note self-sealing is a permanent part of the system. Okay, this is a great example of this. The photo on the left, taking through the post-construction walkthrough, shows a leak that has sealed. And during the 10-year review, we observed these same cracks still dry and leak-free. So Jeff, could you explain on how to properly address the quality assurance and the maintenance procedures?
Yes, well, up until now, we've been reviewing specification and selecting products and systems. But I think it's time to discuss the execution when the job starts. Leading up to placing concrete, it's highly recommended to review your waterproofing details with the manufacturer. This is an opportunity to make sure that the appropriate products are being used in the right places and to their greatest effect. It's also a good idea now to submit your concrete mix design to the manufacturer, who can review it and suggest any optimizations for waterproof construction, and also comment on compatibility between the waterproofing admixture and any other chemical admixtures that may be used in the concrete. It's also highly recommended to hold a detailed pre-construction meeting to set out roles and expectations about how to get the most out of this system. This is also when we would want to train the installers of the water stop. And you'll want to do this even if they have experience with these products or similar systems. It's highly recommended to reconduct that training at the outset of any job. Now, when the concrete starts to arrive, there are additional steps you can take to make sure that everything goes as well as possible. These would include a pre-construction inspection to make sure the water stop materials are installed at the correct location and are installed correctly. You'll also want to make sure that the forms are clean and free of water or any debris that might interfere with the performance of that concrete. And as the concrete is being delivered and placed, it's also important to make sure you're keeping good records of the delivery of that waterproof concrete that can be reviewed by the manufacturer to protect your warranty. Now, once the concrete is in place, another important detail is to make sure that it is properly cured according to the guidelines in ACI 308. Now, these would include either wet curing or the application of an ASTM C309 compliant curing compound. But effective curing of the concrete will give you the maximum properties and minimize the shrinkage and cracking, greatly optimizing the performance of your waterproofing system. And throughout this entire process, you'll want to make sure you're taking full advantage of any additional tools or resources from the manufacturer that would help with effective inspections for the water stops, concrete placement, and post-placement inspection of the waterproof items. Now, once the building is done, is handed over, the owner, of course, is going to be curious about maintenance and maintaining the performance of their new building. So fortunately, crystalline waterproofing systems are inherently durable and low maintenance. But you do want to make sure the owners are aware that they may see some of these white crystals growing around any cracks or joints that have experienced sealing. Now, you can assure them that they are not harmful, they're not toxic. In fact, anything on the surface can be cleaned away. It doesn't have any negative effect on the system at all. If the owner wishes to paint their building, they can still paint the walls. But it is important they're aware that any other systems that form part of the water management for that structure, so these would be your drains and sumps, if they are present, should still be checked and cleaned on their normal maintenance cycle.
Now, we are often asked, can the integral system be used as a standalone waterproofing solution? Can it be used in conjunction with other coatings or membranes? How about using a tank foundation? Yes, it can. The integral system is designed as a standalone waterproofing solution. It's most often used with drain board and under slab drainage. The system is also used as part of a belt suspender solution with externally applied membranes. And we're seeing more and more cities and states requiring a tanked foundation with no permanent dewatering, such as Seattle, Vancouver, and California, which have storm sewers at capacity and will not allow new buildings to run dewatering sumps post-construction. The integral system can be used to tank below-grade foundations. So it's important to work closely with the structural to ensure the foundation walls and slabs are designed to withstand the increase in vertical and horizontal load pressure. The walls will need to be designed with this in mind, and the slab may need to be thickened into a raft slab. So this concludes our presentation for today, and we hope everyone got useful information that can be applied to your next project. Jeff and I will now open the floor up to questions and answers.
Thank you, Jeff and Christian, for this excellent presentation. We now have some time for Q&A. Just open the window located at the bottom of your Zoom window and post your questions. We've already had some come in, so let's get started. The first question is, have contractors and/or AEs presented this type of application, since it is an admixture to the concrete, as a safer application during installation than having trades working at height or within trenched areas that require a lot of safety planning, oversight, and present a possible dangerous condition?
Jeff, you can take that one if you'd like.
Yeah, I'm not quite following the question, other than there certainly can be, advantages sometimes to not needing access to the outside of the building. Often we'll see the designers or owners appreciate that feature because they can fully build out to their property line. But certainly if you can avoid sending workers down into that trench, that can have advantages depending on the configuration of your site.
Okay, perfect, thank you. Another question here I have, no matter how well-designed concrete will still crack, which means a crack repair methodology is still required. How is this done at cracks larger than the limits of self-sealing?
Just doing a traditional crack repair. So route out and route and grout the crack like you typically would. So we have several different crack repair details and methods to properly address those areas. It's very common. It's actually part of the process, because cracks do happen. It's just a part of concrete. So most of the cracks will do self-sealing, but yes, for larger cracks, it's a simple crack repair process that you typically would see on existing concrete.
I have another one here as well. What does the admixture do to the strength of the concrete?
There's no loss of strength. Typically, we'll see anywhere from 10 to 15% increase in strength on the concrete. But what we always advise is just use the standard mix design that you were looking for at the beginning. So if it's a 5,000 psi, stick with a 5,000 psi. You'll get higher strengths, and go from there. So we don't recommend trying to design higher strength mixes with our admix in it. You'll just get that added benefit.
Okay, great. Is there any sealant that is not compatible with the crystalline?
Jeff?
Yeah, I assume by sealant, maybe they're wondering about any sort of surface finish or coating. This may depend on the manufacturer, so you should review that question or any materials you're using with the particular manufacturer, and ask to see any testing they've done and due diligence on the application of coatings, paints, or other materials on their concrete. But in general, there are crystalline admixtures that have no restrictions on any coating or sealer that would normally be compatible on concrete can still be used on the crystalline concrete, but do verify with your manufacturer.
Okay, perfect. I have one more here. How does the system address water vapor transmission across the contratemps wall?
I'll let Jeff jump into that one.
Okay. I'll address the water vapor transmission question. It's going to depend a little bit on exactly what your goals are in that concrete. The crystalline admixtures will typically reduce vapor transmission a small amount, but the concrete still does remain breathable. Now, what you'll find is on a below grade foundation wall, the water vapor transmission on that concrete is actually very, very low. So, you still get an appropriate environment for these parking structures and for use within them. Now, on the other hand, if you were installing a finished area with moisture sensitive flooring, wood flooring, we would still recommend using an underslab vapor barrier, because these products are a waterproofing product, but they would not necessarily be a vapor barrier when you're installing moisture sensitive flooring. So for common parking structures, there's no vapor issues or problems. But if you're installing sensitive materials or flooring, you'll want to still make sure you're protecting yourself in that way. And again, consult with your manufacturer on a specific recommendation in those cases.
Yeah, and same goes with gases such as radon. The underslab, it's meant to protect against the gases coming through the concrete, but having just still breathable, that's where that extra protection still needs to be used.
Perfect. Thank you so much, Jeff and Christian. And thanks to everyone who joined us today. That's all the time we have for questions. If you do need to reach out with any additional questions, the presenter's contact information is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the demo cast within a week. So keep an eye out on your inbox. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey, as it helps us to continue to serve your needs in the future. On behalf of the Construction Specifier and Kryton, thank you again for joining us, and enjoy the rest of your day.